In our last video, we learned about the difference between an empirical formula and a molecular formula. We learned that the molecular formula that we can see here is referring to the actual formula of that compound, and that the empirical formula is just a formula that shows the ratio of the different elements within that compound. So what we're going to learn to do today is we're going to first figure out how to calculate the empirical formula when we are given the percent composition. So from 2 videos ago we learned about what percent composition is. So one of the examples we had was H3PO4, and I asked you what, of H3PO4, what percent of that is, let's say, phosphorus. And so you took the mass of phosphorus, you divided it by the mass of the whole molecule, which H3PO4 weighs 98, and you got a number. And that was a percentage. And so what we're going to be doing now is we're going to be given a percentage, and we're going to have to go backwards, and we're going to try to get the empirical formula from that. So it's not too difficult. Let's just look right through the steps. So first of all, if we're given this problem right here, it says the percent composition of a compound is 40.92% carbon, 4.58% hydrogen, and 54.50% oxygen. What is the empirical formula? The first thing that you have to do is you change the percents, these percent signs right here, you simply change them to grams. And so all that you do is you take your 40.92% and make it 40.92 grams. Take your 4.58%, change it to 4.58 grams, and then obviously here as well, you just literally erase or rewrite the number, and instead of writing a percent, you write grams. Okay, on your second part, what you're going to be asked to do is you're going to convert the grams to moles. So this is something that we've already learned. So if you have 40.2 grams of carbon and you need to convert those to moles, you find the molar mass of carbon from the periodic table, and then the grams on the top, the grams on the bottom are going to cancel. And then you take 40.92 and you divide that by 12, and you get your moles of carbon. And then you do the same thing for hydrogen. The molar mass of hydrogen is 1. And then you do the same thing with oxygen. You take your grams of oxygen and you convert them to moles. And so now we have 3 different numbers, or 2 different numbers, I guess, in this case. You've got 1 for carbon, 1 for hydrogen, and 1 for oxygen. So your first step, change your percent signs to gram signs. Your second step is to convert the grams to moles. Our third step now is you look at your 3 numbers here and you find the smallest of the 3 or 4, depending on how many there are. So in this case, the smallest number is either this 3.41 or this 3.41. So we're going to divide every single number by that 3.41. So this is carbon, this is hydrogen, and this is oxygen. So that means that this formula, 1 carbon, 1.34 hydrogens, and 1 oxygen. Now the problem is we know, like in this case, if we had gotten all whole numbers, let's say this hydrogen here was a 2, then we would actually be done. Then our formula would just be CH2O. But in this case, it's not. Okay, but we still did it right, and that's okay. But, so this is our carbon, this is our hydrogen, this is our oxygen. So again, according to these calculations, the ratio of the atoms in the molecule is this. So for every 1 carbon and 1 oxygen, there's going to be 1.34 hydrogens. But again, obviously the problem is you can't have 1.34 hydrogens, which leads us to our last step. If the numbers in the empirical formula are not whole numbers, such as that, you must multiply them by the smallest possible number to convert them to whole numbers. So for example, 1.34 is basically 1 1/3. And so we should know what number would you multiply a third by to get to a whole number. Well, you would multiply it by 3. And so that 3, again, the distributive property, has to go to all of them. And so in this case, our empirical formula ends up being C3H4O3. Now, this step number 4, this is probably the most challenging step. Step 1, pretty simple. Just change the percent signs to grams. Step 2, not too bad, converting the grams to moles. You know how to do that. Third step, not too bad. You just find the smallest number and you divide all of them by that smallest number. Step number 4, again, can sometimes be challenging. And let me kind of explain a little bit. So these are just the 4 steps again. Change the percent to grams, blah, blah, blah. An easier way that I have to remember that is a cute little rhyme. So this is step 1, 2, 3, 4. So we do all of that together. The rhyme goes like this: percent to mass, mass to moles, divide by small, times till whole. So again, what that means is on number 1, you're changing your percent to masses. Step number 2, you're multiplying, you're using your mass and you're converting to moles. Step number 3, you're dividing by the smallest number. And then step number 4, times means multiply, so you're multiplying until you get to a whole number. So let's talk about step number 4 again, because again, these 3 are pretty straightforward. Step number 4, though, remember, you have to multiply by a number so everything gets to a whole number. Now, here's the problem: is sometimes when you divide by that small number, you don't get, something that's really close. So let's say you divide a number and you get something like 8.03. And you're thinking, okay, what number do I have to multiply 8.03 by to get to a whole number? Well, really, it'd have to be like 33 or even 100. You could multiply 8.03 times 100 and you'd get 803. Okay, you're never going to have to do that. You're never going to have to multiply by a really, really large number. If you got 8.03, you would just round that to 8. So if you got like 7.97, again, you would round that to 8. Here's what you're basically going to find. You are either going to have, like in this example that we just did, you're either going to have a third or 2/3, not time, sorry. You're either going to have a third or 2/3. So you're either going to be really close to 0.33 or 0.3 or 0.67. And if you're close to one of those two, then you're going to multiply your number by 3. Obviously, if you're close to 1/2, so if you're anywhere around 0.5, you're going to multiply by 2. So like 0.48, 0.52, anywhere around there, you're going to times by 2. And then the only other one I've ever seen is if you're at 0.25, again, pretty close by it, 0.24, 0.23, 0.26, or 0.75. Again, 0.76, 0.77. In those cases, you're going to multiply by 4. So your choices are: you either multiply by 2, you multiply by 3, or you multiply by 4. And if you can't figure it out, then obviously come talk to me. But again, you're always going to be close to one of these values here, 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 or close to a whole number such as 9.98. You're not going to times that by 100. You're going to put 10 and call it good. Okay, so after you divide by that small number, it kind of is going to take a little bit of practice. But when we do that times till whole, you're either going to be multiplying by a 2, a 3, or a 4 to get to your whole number. So let's look at another example. It says determine the empirical formula of the compound using the following percent composition: 24.75% potassium, 34.77% manganese, and 40.51% oxygen. So first thing we have to do, 24.75, instead of percent, grams of potassium, 34.77 grams of manganese, and 40.51 grams of oxygen. Okay, and now we're going to go to the periodic table. The mass of potassium from the periodic table is 39.1 grams in 1 mole. The mass of manganese is 54.93, so we can round that to 54.9. And remember, if you just go out one decimal place, you're fine on the masses. And oxygen, 15.99, so that's going to be 16 or 16.0 in 1 mole. So notice our first step, percent to mass, and now we're doing mass to moles. So percent to mass to moles, divide by small, times tell whole. So now I'm going to take my calculator and I'm going to go 24.75 divided by 39.1 equals 0.6. We're going to go 0.633, and that's potassium. I'm running out of room, of course. And then I'm going to go 34.77 divided by 54.9 equals that same number, 0.633. And that's manganese, Mn. And then oxygen, 40.51 divided by 16 equals 2.53. And that's oxygen. So percent to mass, mass to moles, and now we're going to divide by small. So let me transfer this information over here. 0.633 moles of potassium, 0.633 moles of manganese, and oxygen was 2.53. 2.53 moles of oxygen. So percent to mass, mass to moles, divide by small. So we look at all of our three numbers here. What's our smallest number? In this case, again, we've got two of them that are both the smallest number. So we're going to divide by 0.633. Divide by 0.633. We're dividing everything by 0.633. So in this case, for potassium, we get 1 potassium. Manganese, obviously the same number, so 1 manganese. And then for oxygen, 2.53 divided by 0.633 equals, now again, this one's pretty obvious, but it's 3.99. I'm not going to round that or multiply that by 100. I'm going to round that to 4. So 4 oxygens. Now in this case, all of my numbers are already whole numbers. And so I don't have to do anything more special than that, because there's no need to multiply to get to whole numbers because they're already whole numbers. So my formula, my empirical formula just is KMnO4. Now in this case, that actually is the empirical and the molecular formula. Now let's say we have our KMnO4, but in this case they don't want the empirical formula, they actually want the molecular formula. So we've got KMnO4, and in this case, let's say, just like before, if we know the empirical formula, so potassium is 39.1, manganese was 54.9, and oxygen is 16, and there's 4 of them, so that's 64. So let's take our calculator. So we're going to go 39.1 plus 54.9 plus 64 equals 158. So now this is our empirical formula, EF, or this is our empirical formula here. If they want to know the molecular formula, remember there's one other piece of information that they need to give us, is they need to give us the molar mass of the empirical formula. So if they say, all right, you've got the empirical formula, it's KMnO4, but we want you to find the molecular formula. And the mass of the molecular formula is going to be 474 grams per mole. Well, we've already learned this, but let's just refresh here real quickly. If the molecular formula has a mass of 474, we're going to take our number, 474, and we're going to divide 158 by 474. So in my calculator, I did 474 divided by 158, and that is equal to 3. So again, now that we know that it's 3, we're going to multiply everything in here by 3. So our actual formula would be K3Mn3O12. And that is our molecular formula. All right, let me show you one more example. Get rid of this. All right, so let's take a look here. In this one, we've got 37% carbon, 2.20% hydrogen, and 18.5% nitrogen, and 42.29% oxygen. So this one hopefully this will provide us a little bit more of a challenge. So first thing, let's get rid of percents and make them grams, and I'm just going to take those zeros off too. So 37 grams of carbon, 2.2 grams of hydrogen, 18.5 grams of nitrogen, and 42.29 grams of oxygen. So there's our percent to mass. Now we're going to go mass to moles. So 12 grams in 1 mole of carbon, 1 gram in 1 mole of hydrogen, 14 grams in 1 mole of nitrogen, and 16 grams in 1 mole of oxygen. So now I need to go to my calculator. 37 divided by 12 equals 3.08 moles of carbon. Hydrogen, 2.2 moles of hydrogen. Forgot to put moles up there. 18.5 divided by 14 equals 1.32 moles of nitrogen. And then oxygen, 42.29 divided by 16 equals 2.64 moles of oxygen. So percent to mass, mass to moles, divide by small. What's my smallest number out of these 4? Obviously it's 1.32. So again, everything, I'm going to divide everything here by 1.32 divided by 1.32, 0.32, and 1.32. So 3.08 divided by 1.32 equals, so this one here, I'm going to kind of move it down, 2.33. 2.2 divided by 1.32 equals 1.67. This one is equal to obviously 1, and 2.64 divided by 1.32 is 2. So we've got 2.33, 1.67, 1, and 2. So now again, either your numbers are already whole numbers like the last example, or you either are going to multiply by 2, by 3, or by 4. Clearly these are not whole numbers, 0.33 and 0.67. 0.33, remember, is like 1/3. 0.67 is like 2/3. So what are you going to multiply by? You're going to multiply everything by 3. Not just the decimals, all of them. So the carbon, that's 2.33 times 3 equals 2.33 times 3 equals 7. So the carbon, our formula is going to be C7. The next one is hydrogen, 1.67 times 3 equals 5. So it's C7H5. N, again, don't forget to multiply that by 3. N3, and then O, again, times 3, 6. So that is our empirical formula, C7H5N3O6. Now again, in this case, if they asked us to find the molecular formula, and they would give us that mass, and we had the empirical formula here, we would figure out this mass. It'd be 84 plus 5 is 89. 89 plus 42 is 131. 131 plus 96 is 227. So that's our empirical formula mass. But then they might say, okay, the molecular formula has a mass of, let's say, 681. So then again, we would divide our 681 by 227, which would equal 3. And so we'd have to multiply each of these numbers here by 3. And again, that's only if they ask us for the molecular formula. Many times the empirical formula and the molecular formula are the same thing.